JanBask training. Learn and grow.
We are going to cover the machine learning introduction. I can tell you some of the use cases where machine learning is used, the types of data, means the types of problems you can face it. Okay, it's more like understanding the machine learning rather than going through the code like yesterday. Like the objectives for this session, come to know the applications of machine learning, where you can use the machine learning in your problem solving, in giving a solution to the client. Okay, then why machine learning nowadays, and what is the data types you will get it for machine learning: supervised learning, unsupervised, semi-supervised. This slide talks about, you might have visited doctor, or you might have visited bookstore, where may give you some of the reference for some of the good books. Like suppose you are looking for a novel, okay, a good novel by Shakespeare, like that, then William Shakespeare, then you, instead of you searching there, the bookkeeper can also suggest, like, this is a good novel, you can have take a look at this. So like that, then that comes to the doctor, after seeing your health and after going through your previous medical history, it suggests the medicines for you. To this point, how it's possible, like how the bookkeeper or the doctor suggests something for you? The way the solution is, they are having a rich experience of their professions behind them. So uh, you can see, normally because of experience, the doctor, if the doctor is having n numbers of experience, this n is directly proportional to his efficiency, means his accurateness. If the experience is more, then obviously the patient will prefer go to that doctor. Okay, so what do you mean by experience? Experience means he has gained it through the time. Okay, like by passing of years, his the his experience has gained more. Because of that, he is there to guide you or give you good medicines, advice, surgery, or whatever. So that it talks about the same thing and suggests that any suffering from a particular kind of illness, or and what book you should read next. Imagine a machine could do this for you. Okay, so the machine learning is almost doing the same work. That means there is no need of waiting for a guy to have that much of experience. Instead of that, we can give the data to the machine, let the machine train itself, then the output will give what the output it will give. It will be almost similar to a professional output. Okay. So similar to how an expert like doctor, the bookstore or storekeeper, similar to that experts makes an important decision if machine could read the past data. So basically, how what are the steps for machine learning? This slide talks about read the past data. Okay, for machine learning, two things are very much required. Okay, so a huge data set. I would rather say for machine learning, even that much data is not required. But when you are going to have your deep learning network, you will find that you require a lot of data. Then only the model can work efficiently. But for machine learning, obviously you require data. So read the past data, finds out the necessary patterns. What are the patterns available in that data? Patterns in the sense, like, is there any relation between the fields? Okay, if one field is increasing, one field is decreasing, directly proportional, indirectly proportional to the different fields. For example, in a city, you have given a city data. Okay, you want to predict something, you want to predict the population for that city or something. Okay, so for the namesake, you assume that there are two columns, one is population and another one is area. What's the area of the city? Normally it is in square kilometer or square mile. So if you see that mostly I'm talking about the populated countries like China, India, area is more. That means the population for that city is more. So you will see a pattern of relation. They are directly proportional. Okay. So that is about the necessary patterns. Learns from them. Okay. After finding, the machine try to learn them. Okay. Assuming that if the area is this much, then the population is this much. So first and it will find the relation, then it will try to make it into a function. Normally, if you know, machine learns in 0 and 1, okay, binary codes. So then it will put into a function. What's the relation, all these things it learns from there, and take human like decision for problems of interest from the real life. What's the difference between machine learning and artificial intelligence? The machine learning part is it finds the data, it takes the data, it reads the data, it finds the pattern for the data, and it gives you like the output. When the fourth point comes, that is when the machine make the decisions like a human, then it is the AI. Okay, in machine learning you can get the output, but you cannot make the decision. When the decision comes, then it's the AI. For example, what is the types of decision in AI? You can take the stock market, okay, trading. If you train with your data, then with the machine learning, then you can get the output in the sense whether a stock to buy or not. Okay, if you are having a classification problem, that is you want to identify two outputs, only to buy or not, then you can get it there. But the machine will not do the actual buying. Okay, so when it comes to the AI, when you integrate the AI part, then the machine will have the capacity to actually buy the stock for you without your inference. Okay, the machine will identify, okay, this stock is going low, 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 now this is the time to purchase, then it will purchase the stock automatically for you. Okay, so this is called AI, when a machine starts to take the decision like human. Applications of machine learning. Yeah, this is the slide. All of you should look into this. What all the kinds of things we are gonna do with the machine learning? First is the prediction. Okay, so prediction is something like you want to predict, like you are given the data. Suppose you are the project manager, you are the sales manager for a company, and you want to predict the data, what would be your sales for the next quarter or next month. Okay, you are given a month wise data or year wise data, in that month is also there. So you train your data with a machine learning algorithm and find the pattern in the data, ask the machine to predict the sales for the next month. So that is called prediction. A prediction is mostly called the regression. Okay, like the model name, wherever you see the regression, that means it's nothing but the prediction. And next one is classification. Classification, as the name suggests, you want to classify the things between positive, negative, between yes or no, like the binary output. Binary means two. Okay, so the binary output is called the classification. Okay, classifying an object or subject among one of the several classes, and deals with the factor. Okay, what's the several classes? Suppose you are given a data set, a huge animal data set, okay, pet data set. There are many pets in the world. You can have a cat, you can have dog, you can have parrot. Okay, so the tiger. Okay, all these are pets data sets, it's given. But data sets consist of only the images. Okay, the dataset consists of entirely 70-80% of leveled images in the sense, it is saying that if a picture is there, then it's cat, if a cat's picture. If a dog's picture is there, then if the output is means the level, the target dog is given, then it's called the level dataset. Labeled means your output is given there. Those are the classes. The number of classes means it's the number of outputs, different outputs you are going to get. So in this pet data set, the dog, the cat, the parrot, the tiger. If you see the four outputs, four classes of outputs, means in that several classes, it is only of the four classes of. Now coming to the recommendation system. Recommendation system, I think all of us would be going through in our daily life. If you want to buy something from the Amazon, and then Amazon recommends you something like last purchases based on your the search history, like that the Netflix, where it recommends you the videos, any new series. Okay, so this is the recommendation system. Then outlier detection, finding out odd man out, mostly outlier detection, we call it anomaly detection also. So anomaly is something which is different from your daily thing. Okay, so that is called anomaly. So like that, a bank wants to find whether a transaction is fraud or not, because all of your transactions are there with the bank. Normally per day or per month, you are having a transaction of around $5,000, but that month suddenly it has raised to thousand, $50,000 withdrawal. Then the machine finds there is some anomaly. Okay, so immediately your transaction will be stopped. You will get a call from the bank whether it is going to be, that's the person is you or not, who are going to means doing this transaction. So this kind of things you can do with the outlier detection or anomaly detection. Anomaly means something different from your current thing, means what you were doing. Information retrieval can be many kinds. Reinforcement learning. Reinforcement is nothing but it's the chatbot. You nowadays you might have seen, once you go to your bank site, once you visit to some of the real estate property site, the chatbot is there to assist you. Now there is no the third party customer care. Now chatbots are being enabled to do the job of customer care for you. So that is called reinforcement learning. That is learning by itself. Okay, chatbot produces something, then in the, if it is right or wrong, or the customer wants more information on that basis, it learns it from its previous experience. That is called reinforcement learning. All these things, almost I have told you, like face detection is there nowadays in every mobile almost. Okay, that's also that the Apple or your Google Pixel. Okay, so the iPhone, the face detection, basically in the industry, the face detection was started by iPhone. Okay, so it is one of the leading breakthrough in the technological field, face detection. So that is the speech recognition, image classification, I told you, like identifying the dogs, cats, all this. Fraud detection, that is the anomaly detection. And Netflix, Amazon, YouTube, these are the recommendation. And self-driving cars. Self-driving cars are now the today's in the technological field. Now the machine learning types of data broadly: the supervised, unsupervised, semi-supervised. Okay, supervised in the sense wherever somebody is telling it's a supervised data, that means you understand one thing. For the data, predictors are there. That means the columns, the feature columns are there, and the output is also there. That is called the supervised data. Okay, the target or level is there. We call the output that is target or level. For example, in a city data, you want to predict the population for the city, and what all the predictors you have got it. First one is city name, and next the country name. Okay, the third is the area available in the city, and the fourth is the weather. Obviously, if you go to a good weather place, then the population would be more for the city. And if you go to the Greenland, then obviously Siachen border China, then obviously it's not there. So these are the places where human cannot live, so the population would not be there. for this data set, all these fields like name of the city, the country, the weather, or the area, all these are the predictors, and you're trying to predict the population. Okay, so that's called the label. Suppose you are a manager working with a company, any of the automobile companies like Audi. You are working with Audi. No, everybody knows it sells luxurious cars. Okay, you are a manager over there. Okay, a strategist over there. You have given the customers data set, and you want to find out which customers are up to which group. Then you can focus them with the different advertising method. Okay, suppose a young customer is there whose age is below 30-35 years, then you can focus him with your SUVs. As the time passes, if the customers you are having a group of customers who are into the 50s or 60s, then they you can focus more for a sedan car selling to them. So like that, to identify the different advertising method, the different amount of discounts you can offer, okay, the feature you can provide to them, on that basis you can increase your sales. To identify that grouping, we do the clustering. Okay, so clustering is nothing but getting the data, unsupervised data, clustering, and finding the pattern among themselves and making it to divide into a different clusters. That is called groups. Semi-supervised, as I told you, like if the 70-80% of your data is leveled, another 20% is not leveled. So that is called the semi-supervised. Why the machine learning required? Obviously, it will do the work 24/7 for you. Okay, there is no need of waiting for a professional. You can learn the machine, means train the machine, and then the machine will start behave like a professional. It will give you the advices, it will predict the data for you. Okay, better products, services which can be even customized. So basically it can say that it will save the human time, and it can reduce the human error. Human error in the sense, suppose you are doing something, a doctor is scanning through a x-ray, okay, or a CT scan. Okay, so there could be chance that the doctor may miss the minute things in a scan, okay, in a x-ray. But if you train the machine with lot of images of the x-rays of your any of your body parts, a little bit deviation from the normal pattern, then the machine will quickly identify. That part will come in the computer vision, how it works. But for the time being, it reduces the human error. So the requirement here, what's the requirement of the machine learning or the deep learning in today's data science? A lot of available data. So this is nowadays not an issue. Previously it was headache for all of the scientists how to get the data. But now you see that for Facebook 100 terabytes of data are generated daily. For Google 3.5 billion queries per day. Okay, so a huge data available nowadays in the market. Okay, for the Twitter, YouTube, all these. And second is much better computing power to process the huge data. Nowadays if you see, previously to have a RAM of 1 GB to your computer, it was a huge cost. Okay, and normally people used to prefer 1 GB or 0.5 GB, 512 MB RAM. Now if you see, the RAM power has easily increased to 16 GB, 8 GB in our own laptops, personal laptops, almost to in the terabytes to some of the supercomputers. I mean to say, now the data is plentifully available and the computing power is there for the machine. Now moving to the data types, there are two data types: structured data, unstructured data. Structured means, structured is nothing but a tabular data. Tabular means you are getting it from server, that is the RDBMS relational database like MySQL, or any of the tabular form like in the Excel data. All is the structured data. Whereas unstructured data is your emails, your audios, okay, graphs, videos, all these are unstructured data. And that means the data is not visualized, because for the voice you cannot visualize, for the audios, the series, yeah, for images you can visualize those things, emails, but they are not structured, they are not put into a column or rows. I have told you that I've given you an example of that automobile company. You are working with, suppose, Audi. You want to find the clustering part, like you want to group the people based on their behavior, based on their age, based on their purchasing pattern. Okay, so that you can focus on them more differently from other group whose purchasing pattern is and the age and other attributes are different. So that is the unsupervised learning. Unsupervised learning is a machine learning task that infers the function that describes the structure of unlabeled, unclassified data. The data, as I told you, there is no level data because there is no the target column, and it's unclassified. Obviously, when there is no level, that means it is not classified. Okay, you can take the examples, the what I have given you earlier in the anomaly detection, the bank fraud. That's what it talks about. If you work for a multinational bank, the bank's customer are at all sorts of the fraud risk. If you have frauds classified into various types, suddenly you see some abnormal behavior on one of the customer's credit card transaction, but your system does not have any appropriate classification to for this behavior. The solution is anomaly detection technique. Okay, so that is normal versus not normal behavior. Like till this point, for so many years, your withdrawal is less than, suppose, 10,000 or $20,000 per month. Suddenly it has increased to 80,000, 90,000. Okay, like that. For the machine, it's an anomaly. So it will quickly block your transaction. Unsupervised learning technique. So the learning we are going to have, one is clustering. Okay, the clustering is the main part. I would say clustering and dimensionality reduction, and others are almost the recommendation systems. What is curse of dimensionality? So the curse of dimensionality, this term you will come across in, once the course proceeds, you will come across so many times. Okay, and while do it data pre-processing, you will come to know there is called the curse of dimensionality. So the what is the curse? The curse is, suppose you are given a data field, okay, which is having around 100 attributes. That means 100 columns. Okay, it's a huge data field you have gathered. Or you can say a bank's data field, bank customers data field. The bank takes everything, the transaction, the customer history, the customer, customer is married or unmarried, okay, the number of children he or she is having, everything, the information you give it, right? So you are given a customer data set, but you are not given enough number of data for, you have given only the data for 100 customers, but whereas your data, each customer, there are 100 attributes are there. He or she is married, where she lives, what's the income, the credit card, whether he or she is having, like that, the different attributes are there, columns are there. And but you have given only 80 or 100 customers data by the bank, and you being asked to do a prediction of certain kind for that customer, or means for that data set. Suppose we can take the problem statement like this: the bank wants to sell the personal loan to those customers. Okay, there could be a problem that is called the curse of dimensionality. That means you are given a huge attributes for the data set, but you are not given enough data. Okay, that is called curse of dimensionality. Okay, so if you see, it's, sorry, CURSE. Okay, this is a curse. It's called curse of dimensionality. These are the columns, suppose. Okay, basically here, these are the columns. Okay, like 1, 2, 3, 4. These are the columns, and for each column, rows. That is 1, 2, 3. Okay. This one talks about your income. This one talks about your something, the credit card you are holding or not, yes or no. Okay, like this. And this is the record about you. Okay, this is the record about Pal. This is the record about Kings. Okay, like that. What machine tries? Machine tries to identify the pattern between this one and this one, this one and this one, like this. Whatever the permutation combination available, like that it wants to find. That means the machine finds the relation among columns. Okay, not among records. Okay, here there is no relation. These are the individual records. The machine tries to find the relation among the columns, but for that it requires huge number of rows, so that it can quickly do the sampling, it can quickly do the function, like how the machine trains itself. It can choose the sample, like out of 10 data, every time the machine will choose randomly the 7 data among around 70% of the data for the training. Another 30% it takes for the testing at each round. So like that. So that's why it's called the curse. You are having many columns, but you are not having the similar or directly proportional number of rows. So there would be a less learning by the machine, unable to train itself. Okay, this one is having a highly correlated to 3. That means 1 is related to 3. Okay, and 2 is related to 4 in our data set here. Okay, so what we can do, instead of keeping 1 and 3 both, because these are almost similar, we can keep only 1 or 3. 2 and 4 are mostly similar kind of data they are giving. Okay, like if one increases, then the fourth, means if the second increases, then the fourth also increases into certain number. Suppose the in second, if the field value is 2, then in 4 it's 4. If it is 5, then it's 10. Then what's the pattern? Like it is being multiplied with the double, 2 to 4, 5 to 10, like that. So instead of both the fields with our machine learning algorithm, we can keep only the second one. We can discard the 3 because it's highly correlated to this one. The data, whatever the present in the 3 is almost there in 1. Likewise, we can discard the 4. This is called dimensionality reduction. You are reducing the dimension. Okay, you are reducing the number of attributes. Okay, so this is the dimensionality reduction. Anomaly detection, I have told you, finding abnormal behavior like the transaction. Okay, what you are doing. There is called market basket analysis. That is nothing but we will come across the recommendation system. That is a type of recommendations, market basket analysis. And you have gone to a website where you can get it. Once you purchase something, based on your previous purchases, they recommend you something. Okay, suppose you have got a vegan milk, then next time they will suggest you go with the vegan butter. And here the supervised is almost all data where a label is there, output label is there. That means whether it's binary yes or no kind of thing data. Okay, if you see, it's a bank data. Okay, the objective was to find out personal loan modeling or selling, like whether the person can take the buy the personal loan or not, agree to buy or purchase the personal loan from the bank or not. If you see, this is a label data. Okay, because the personal loan column is there for the data set, entire data set, and it is labeled like 0, 0, 0, 0. And if you see in the personal loan, it's why it's called label data, because you have given all the features like ID, age, experience, income, family, okay, education, mortgage, okay, whether you are having a security account or not, you are having a credit card or not, you are having a online banking facility or not. Okay, so 0 means you don't have, 1 means Yeah, this customer is having. Here the target column is the personal loan. It's labeled because with this ID, with this age, this person is not willing to buy. So that's why it's 0. Okay. And you see here index number 9, this person is willing to buy. Okay. So likewise, the all entire data set is labeled. So that's why it's called the label data. That means where your target column, this personal loan is called the target column. Okay. So this target column or label is there available for the data set. That's why it's called the label data. Like what is supervised, unsupervised, how it is. Okay. So for the time being, wherever the label is not there, okay, that's called the unsupervised. And what all the unsupervised includes recommendation system, time-snarled direction, and the third one is the clustering. Okay, so as I showed you, it's a input data, the output level is given, so that's called the supervised. So whenever new data comes, whatever the training you have given, it will pass through that and it will predict the level for you. Then the classification, types of problems where the output variable is a possible category. Like the previous example is a classification problem. You want to classify the customers among personal buyers interested or they are not interested, 0 or 1. That is the classification problem that I showed you. Regression like sell value. I told, assume that you are a sales manager for a company, you want to predict your sales for the next quarter or next month. That's called the regression. So mainly supervised are two categories, classification and regression. Many of our problems are unsupervised, semi-supervised. Okay. Most real world problems fall into this category because you cannot find the data for all the label for all of your data. You can divide the data into supervised and unsupervised. You try to model or predict through supervised in the same data sets. Okay, this is the data set given to you. Okay, it's a classification problem. You want to classify the personal loan between 0 and 1, whether the person is interested to buy or not. Okay, a new person comes. Okay, what will you do? What's the use case for this machine with your data set? Now machine is ready. Whenever you give ID, age, experience, income, zip code, all the fields, then it will predict the personal loan field for you, whether it's a 0 or 1, that will predict. So the real world problem is like this. Okay, for a customer, the ID is this one, ID is no relevant, age is this much, experience this much, income is this much, and all this code, whether he is going to take the personal loan or not, yes or no. That's the real world problem. It comes under supervised, and your testing data, that's your actual data, what you are going to predict, is unsupervised. Obviously, if you have the result beforehand, why do you require a machine? Okay, when you know that a person is not going to buy, then why you require machine? That is simple logic and you can discard. The machine requires when there is a probability that okay, this person might be my client. To know whether what's the probability with this one, then we proceed with the machine learning. What's the probability that the person will come to the bank or will be customer for the bank? So for this we require this entire machine learning.
JanBask training. Learn and grow.